Hey, welcome back to Pacifica Science. If you check out the board behind me, it's got the notes for the 21st, which is today, and the 22nd, which will be the classes 4th and 6th period tomorrow. Wanted to go a little bit over some of the things that you saw in current events today. And one of the things that was on current events in CNN 10, which I used this morning, was about growing an apple in Colorado that was thought to be extinct, but they're trying to bring it back. It's very similar to a story we had last week where they're trying to increase the variety of the foods in the marketplace. Really cool article there, and it's exactly what we're studying, evolution, natural selection this year. The other thing is the first note, and if you check out the very first note, it's about Ruth Bader Ginsburg and the opening on the Supreme Court. Unfortunately, Justice Ginsburg died this week, and when you see that the note up here says there's 9 spots on the Supreme Court. On the one hand, it's current events. We should definitely, especially in middle school, be starting to read a paper. If you don't read a paper anymore, a lot of us get our news online. Make sure you're keeping up with the current events and what's happening right now. You really are in historic times. I mean, it's technically always historic times, but there's some extraordinary things going on right here. And also, what we're learning in this class, the crossover with the other subjects is constant. If you look at Ruth Bader Ginsburg and the Supreme Court, for example, one of the books that we talked about earlier in this class was Darwin's on the change of species, on natural selection. And when you look at a case in the United States, the famous Scopes trial from 1925, there was a teacher. He actually wasn't even a science teacher, he was a math teacher, but he was teaching a little bit of science. This happened to be in Tennessee. Same thing happened in Texas. These things happen all the time. He was actually fined. He was actually brought to trial for teaching evolution. Natural selection would be the proper term in his high school class. It turns out they did find him guilty, but it brought to the forefront that things like evolution, natural selection, it's hard to believe, but these things actually can still be controversial in some places in this country. As a matter of fact, you could make the strong argument that science has been under some increasing assault in this country. That's why we're in this class. That's why we do current events. You don't learn the science in here in a bubble. We are learning things that are connected to our community and to the world around us. One of the next videos I want to put out there talks a little bit about the ecology and the geology of Pacifica, and that continually through the school year is something I want to drive home to all the students. It's not just about remembering things for a test. If we really see how these things affect us on an everyday level, for example, the faults that go through town, the biology of the things that you see right out here in the ocean, right here on the land around town, those things, they stick with you. And also, it's more beautiful seeing the things that are around you. You start really having an appreciation for what's going on. So that was the first note about the 9 spots on the Supreme Court. The other one is a really good article on CNN today about Colorado trying to bring back something called the orange apple. It's a type of apple. It was thought to be extinct. Extinct will be one of our key terms, I believe, next week. And they thought it was gone forever. When something is extinct, it's basically gone forever. It turns out there's somebody who found one, and they're trying to bring it back. Remember, the variety of food in our marketplace has really dropped over the last couple of years, and this is an attempt to bring something back. Okay, after we went through our current events, we talked a little bit about the seasons. Remember our seasons? Summer, and of course we're moving into autumn now. Then you have winter, and of course we'll be going back into spring, and we have them because the earth is tilted, and we talk a lot about the connections between astronomy, geology, biology. Obviously, if you're talking about a connection between astronomy and biology, we're talking about seasons and the fact that our earth is tilted about 23 degrees, 23 and a half degrees with respect to the way it revolves as it orbits our sun. If it did not have that tilt, if it was, in other words, just spinning straight up and down relative to the sun, it would essentially be the same climate. I shouldn't say climate, it would be the same basic weather patterns all year long. But because of that tilt, we get nice little seasons. Just talked to, for example, my brother yesterday, and he, even though we grew up here in Millbrae, San Bruno area together, he moved back to New Hampshire, and it's already getting down below freezing at night back east in New Hampshire. So that's chilly, freezing 32 Fahrenheit, 0 Celsius. Again, straight out of what we're learning this year in terms of the seasons and how they affect biology on this planet. Okay, we revisited water. And one of the things, and this ties into the thing with the seasons, water stays liquid over a very wide range of temperatures on this planet. When you look at solid, liquid, gas, plasma, the 4 states of matter that we studied in this class or that we had in our notes, remember there are other states as well, but these are the 4 main ones that we talk about in this class. Water has this amazing ability compared to other compounds to stay liquid all the way, from 0 Celsius to 100 Celsius. From 32 Fahrenheit to 212 Fahrenheit, it's a liquid. That makes it a wonderful solvent, and then we want to get into a little bit more. What is a solvent? Your reading had solvent in it last week. What does that mean? Well, water dissolves other compounds, and we did, for example, and this tied into the experiment that we did in class today, a leaf rubbing. About 2 weeks ago, we did a rubbing of a leaf. We wanted to check out the patterns in that leaf. We wanted to work on our observation skills, and we want to think about why does it have the shape that it does. One of the examples we gave in class was this. We'll get into the phrase form follows function in a moment, but if you've ever seen a movie like Jurassic Park, and they have a paleontologist in the movie, might say something like, oh, well, this tooth came from a meat eater, a carnivore, as opposed to an omnivore or an herbivore. And somebody might say, well, how can you tell? How can you tell that that tooth of a dinosaur that's been gone probably for more than 65 million years ate meat? It's been gone for tens of millions of years, yet we can tell its diet based on the shape of the tooth. Pointy, serrated tooth, like a shark tooth or something like that, you can tell that it's made for cutting, ripping into flesh. A big flat tooth made for grinding down plant material. We are omnivores. We've got some flat teeth. We've got some pointy teeth. And you can tell what something does by its shape. That's really an important concept in biology. So we moved on. I'm going to switch the screens here. We moved on to our experiment in class. And our experiment was basically this. Remember, we try and adapt them all for use with the online learning. But we talked a little bit about how nature has made the perfect solar cell when you're looking at a leaf on the last slide, and also on the notes, which are at pacificascience.org. The notes for today will be out there shortly, and they have also been sent home on email already. The notes out there try and show that a leaf is kind of like a perfect solar cell. We've all seen solar cells on the tops of buildings and things like that before. The job of a leaf is to get the water from the ground up to a place where it can then use sunlight and water, and that water can use sunlight and carbon dioxide to make the sugar and to exchange the oxygen with the atmosphere. It's the perfect shape for what it does. Form follows function. It's actually a term originally used in architecture, of all things, but it's a really important term in biology this year, especially as we go into studying natural selection. Our experiment was simply this. And I'm going to reach over here and show you. I colored the water a little bit so we could see it. We took salt, just table salt, NaCl. That's a sodium atom and a chlorine atom bonded together. We'll talk a little bit about more what that means more next week. Basically stuck together. And if you look at the salt and the water, we poured a little bit of the salt into the water, gave it a little shake and dissolved the salt. And the students were challenged to think about this. Part is just take an everyday coffee filter. And the students were also invited to follow along in the class if they happen to have these materials at home. I try and keep it so it's something that we can do perhaps with things that are laying around the house. When you poured the water through the coffee filter, how much of the salt did you get back from that salt water? Some students guessed that there'd be little bits of salt back on the filter, but in reality, after we poured it through, the wet coffee filter had no salt left on it. And the students were then challenged to say, why? What happened? What does dissolving really mean? Most of us have the feeling that, well, okay, the salt disappeared. And we are going to go into a little bit more detail tomorrow. Where did it go? What happened? We've touched on what's an atom. We've touched on what's a molecule. Again, we're not getting too deep into that chemistry. That's for 8th grade and beyond. But we need to understand with those atoms what's going on. Where did the salt go? In other words, put it a slightly different way, I had filtered it into a beaker. That last one was a flask. I don't usually spend a whole lot of time giving a test on what's a beaker, what's a flask. We learn these things as we use them in class. This large container is a beaker. It's got the colored water in it. If I were to drink this, which I won't do, it's salty water, and the salt is still in there. Why can't I filter it out with a fine paper filter? Or if this doesn't do the job, maybe even a filter with smaller holes in it. Why can't I take the salt out like that? That is the subject for this week, really. What's happening at the atomic level, at the molecular level. When you jump into our textbook, you have already seen the word molecules, the words atoms. We want to have a picture in our heads of what's going on. Where did that salt go? So the quick recap this week, we had the 10 terms. Again, these 10 terms are out there with the notes online, but they're hard to see on the board right here. They're the 10 terms that we're defining this week in our notes. Our Wednesday test is due Wednesday by 3 p.m. Please notice that the tests kind of build on themselves. We have our notes over the course of the trimester that go into our interactive student notebook. This is where we get into the idea of what does it mean to be an interactive student notebook. It means that we don't just have all our things written down for the week, take a test, and then forget about it. It builds on itself. We go back on things that we did a couple of days ago or a couple of weeks ago. It's really, really important. Remember, it's your notebook to keep adding to. We use this throughout the year. And then finally, our reading this week is going to be pages 27 through 36 in our textbook. So check out these terms. I'll go into more detail on solutes and solvents tomorrow. So I'll make another video tomorrow and also put out a few more notes tomorrow because we're kind of ramping up a little bit here, and hope you have a great week 5. Enjoy your last day of summer. Get outside, get some exercise, get some fresh air. It's a glorious, beautiful day out there. Finally, the last thing is I went outside the classroom, and I'll put this on tomorrow's notes, I guess, is the shadows. The shadows are getting longer, and also the shadows are changing direction a little bit. And it's almost as if we've insulted the sun and it's starting to go away. In other words, the sun is lower in the sky and it's moved to the south a little bit. We want to find out, okay, why? It has to do, of course, with the tilt of the earth. And as we move into autumn and then winter and the solstice, the days are, from now on until December 21st, the days are going to get shorter and shorter. The nights are going to get longer and longer. Take care, everyone. Have a great day. Bye-bye.